Alright, so first thing we're going to have to do with the red boards is put a custom firmware onto them to interface with LabVIEW. So there actually is a library already on, it's going to be on the machines in the lab. So I'll update that tonight. But if you want to go ahead on your personal computers, that's fine. You can download this as well. So if we go into LabVIEW, let's just make a new project. I've got 2014, the 15 is in the lab, so it really doesn't matter. I'm just going to make a new project. And moving forward, that's basically what you want to do. You want to just make a new project versus a new VI. That way everything can kind of stay together. So let's go and make a new project. I'm going to go ahead and save this project as Lab 7. Let's save it on the desktop. New folder. Test. Alright, so then you're going to go under My Computer and just make a new VI. So this will come up as untitled, so we'll go ahead and save it as well. So let's save it as main. Alright, so, and again, I'm recording this here, so because he's trying to write some notes, that's fine. Alright, so Control T will tile the two windows. So if we go, again, this is going to be in the one in the lab. If you go down towards the bottom, there's going to be this Arduino palette you can work with. So if you kind of remember a couple labs ago when we dealt with LabVIEW, the basic flow of any program is going to be to initialize something. In this case, it's the Arduino. So let me go ahead and spread that out a little bit. Then you're going to want to close at the very end. So what goes in the middle is going to be essentially our main code. So let's go ahead and place, let's do something simple. Let's go ahead and place a while loop in here. Got to have that. And I'll go ahead and place a flat sequence. So basically what I'm going to try to do is recreate the simple code of just blinking the light. That's probably one of the basic codes you start off with the red board anyway, or RedBot. So let's just add another frame here. So this will be light on. And also to make comments in LabVIEW, just double click anywhere in the white and you can start making comments, which is kind of nice. You also, in newer versions of LabVIEW, like 14 and 15, you actually can take the little arrow and point it towards things. Okay, you can reference certain things. So, like for this case, I can say init Arduino, and then I can tie that particular comment to the board. Okay. Again, some of the stuff we went over, but I kind of wanted to reiterate some of this stuff. So you want to go into your VISA resource name and make a new, or excuse me, create a constant. It'll go ahead and search for what's attached. So you can go to your device manager and just double check to make sure that the board is connected and it has its own COM port. So in my case, the board is under COM6. So again, yours is going to be a little different. So it shouldn't be anything new at this point. You can click the drop down box. It's going to take a second. Then it'll say COM6. Let me kind of move this a little bit more to the right. So the resolution on here got kind of small with the projector. Alright, so the default values are going to be in parentheses of any kind of LabVIEW VI. So the default baud rate is fine. We're dealing with a UNO, which is basically what the red board is. So that's default, that's fine. Bias per packet, leave that the same. Connection USB serial, it's basically what we have too. So the only thing we really have to do is define that it's COM6. This is equivalent of going into Arduino and choosing the COM port, okay? So next thing you want to do is notice on the output, again, inputs are always on the left-hand side of a VI or a sub-VI in this case in LabVIEW, and outputs are always on the right-hand side. That's just the convention. So we'll go ahead and tie that into the while loop. Now, a couple things we have to dig into, and this is actually a pretty good exercise for everyone for your future endeavors. So if you look at the base code here for the LabVIEW base firmware, basically all they've done, it just had a couple of includes. So servos for the motors, SPI, and some wiring is for some communication. So a very simple code here. So basically what you're going to do in the lab, you're going to navigate, and the guide online is for this. I'll put some links up on the web page. But basically you're just going to navigate to this path, which goes under LabVIEW 2014, VI lib, LabVIEW host for interface for LabVIEW firmware, and then this is where you're going to find the sketch. So I'm going to go ahead and open this up with Arduino and go ahead and burn this firmware to the board. Again, you have to burn this first before you can do anything in LabVIEW. So I'll just go ahead and compile it. Should go ahead and compile. And then I'll go ahead and download that to the board. And I'll try to switch back and forth when the light blinks on here in a moment. Alright, we're going to upload the code. Should upload just fine. Looks good. Alright, so this code itself doesn't do anything. So there's no light blinking. All this does is get it ready to accept stuff from LabVIEW. So we'll go ahead and minimize that and minimize this here. If you want to look at some of these C++ files and how they do stuff, that's fine. You can do that on your own time. Alright, so if we look at the RedBot library, so if you recall, let me go to downloads here. So does everybody have to download this RedBot master library and put it into Arduino basically when he was working with the RedBots in Arduino? Did everybody do that? Okay, so if we explore this a little bit, and normally y'all don't get down to this level, but I thought it was interesting to add this. But if you go to the source file, basically what they've done to make your life easier, y'all have like motor.break essentially. That's essentially a class in programming. So they basically take away all the lower level abstraction stuff. But in our case, I actually have to know what this is. So I'm going to go into the header file for the RedBot and look in here and find some useful stuff. So they've defined some of the Arduino pins for you. So the left control and right control for the motor control, this is all the left motor. That's tied to pin 2 and 4 of the Arduino, which is the red board. And then also the PWM pin. So they actually make a note that the controller that SparkFun uses for this is a little bit funky. You have to define the direction with these 2 pins, and then you set a speed with the PWM pin. So y'all went through an exercise earlier in the semester where you figure out, enable A, enable B, what the speeds and stuff should be. So it's a similar situation. And again, that's for the right-hand motor. So kind of keep a note of what those are. Again, I'm gonna have this posted and stuff in the example code, but in future, anytime you're working with something that's you've moved the abstraction up so far, sometimes you have to go down and look at the source file and figure out how they're actually connected. So we're going to be using that knowledge here in just a second. Let's go ahead and see if we can make the light blink. So the light on the red board is what pin? D13, right? So in case you don't forget, let's go back to the dot cam. Look at that. So zooming in. All right, so D13 is the LED, so digital pin 13. All right. So let's go ahead and initialize that. So the good thing about this LabVIEW for Arduino interface is it's laid out similar to the Arduino IDE. So if we go under low level, we're going to find some familiar stuff like analog read, digital read port, digital write. So you also can set up a port. So I can set digital pin mode. This is the same thing as pin mode function in LabVIEW, or excuse me, Arduino. So let's go ahead and just set up D13 as a input. So let's make this 13. And pin mode's input or output, we can create a constant. So I've talked with some of y'all about this, but in LabVIEW, when you right-click on any one of the pins, essentially, so these are just the inputs and outputs of the sub-VI. The default value, of course, is going to be in parentheses, but also you can hit create, and you can choose from 3 options always. You can create a constant, a control, or an indicator. Okay, so controls are only going to be for inputs, obviously, and indicators are only going to be for outputs. Okay, so that kind of makes intuitive sense. In this case, we're going to use a constant because it's only going to be either an input or an output. That's not going to change. That'll give us an option for a drop-down box. So in this case, what should the LED be? Input or output? Output, okay. So we're going to choose output. Now it's going to require us to have this Arduino resource tied into here. And the reason why that is, think about that as like a function inside of C, right? You have to declare the function first and then use the function. So it's a similar thing in LabVIEW. So I'm going to tie that into the Arduino source on the input. And then let's just tie the output into here. So essentially what I've done is told it, the Arduino, okay, I want digital pin 13 to be an output. Okay. So now what we can do, we actually can use that and set, or we can write the digital pin. So let's do a digital pin write here. I'm going to tie in the Arduino resource name and the error in, error out. That's actually useful in case something happens. You can always see what the error was. LabVIEW is not exactly well known for having really great error debugging, but nonetheless you can look at it. So in this case, the digital I/O pin is 0, so we can create a constant. We have to tell it again that it's pin 13. And we want to tell it the value, so it could be 0 or 1. So let's create a constant. So for the light on, what does the value need to be? 0, 1, 1. Enthusiastic crowd today, I see. All right.
Always.
All right. Tough crowd. All right. So another thing we're going to have to do is delay this execution. So again, this is a flat sequence. So the first sequence happens, then the second sequence happens. Okay. And again, there's tons of resources out there for LabVIEW, but you're going to go under timing, and let's do just a wait millisecond. So I think the default program for the RedBot was what, on for 1 second and off for 1 second, I believe. So we'll do something similar to that. So we'll go to the left of this milliseconds to wait, and we'll create a constant of 1,000 milliseconds, which is 1 second. I'll go ahead and put that over here. And in LabVIEW, if you select something and hold Control, you can make another copy out, which is kind of nice. It kind of avoids the Control-C, Control-V. Okay. So essentially now what we're going to do is copy this portion over here and make the light go off. Again, we have to tie in our resource name and our error out. Okay. Now we're still getting an error here because the while loop doesn't have a stop condition. So we can just right-click on that and create a constant. All right, and then we're going to tie this out to the close. Okay. Oh yeah, thank you very much. I'd like to be off. So now what should happen is the light should go on for a second and then off for a second. So you've not got any errors, which is good. Most of the time, if it is, you can double click on that and it'll tell you what you're missing. So let's go ahead and run the code. Let me switch over to the doc cam. So what should be happening now is the light. Turn the lamp off here.
Actually, it was pretty quick.
Okay. So you'll notice actually that the TX and RX lines are blinking. That means it's waiting for a second and going off for a second, so it's constantly communicating with it, okay? So if you accidentally unplug it, essentially you're going to see a message like this pop up in a second. Usually it'll die. The instance of it will die. This time it didn't, but you'll see a big error message pop up saying we can't communicate with the board. So let me go ahead and stop that. Okay, so that's wonderful, but that's just a light, right? So next time we want to do is work on getting this thing to move. Okay, so let me kind of move this up top here. Move this up here. Give myself a little bit more room. Any questions so far about anything I went over? Do not care. It's Wednesday. It's not even Friday. It's like Wednesday. This is supposed to be the peak. This is technically our Friday. Well,
is this loading it? Like, so this program here, it works more like a remote control talking to the...
Yeah, so the firmware that we downloaded to the RedBoard from that folder essentially is the middleware that talks between LabVIEW and the Arduino board.
Okay. And so, like say it had an independent power supply, like you unplug it, then
yeah, it should run that exact code.
Okay.
Yeah, so basically what that firmware does is it basically compiles the LabVIEW code serially into what Arduino is looking for, which is its particular code.
Okay.
Okay. It's kind of acts as a middleware for that.
But you will be allowed to take your PC off and run the motor.
Yeah, unless you want to see some real-time values like the particular sensor or particular motor encoder value or something like that. Just like before, you have to actually have it physically plugged in to see the serial monitor. Same thing on here. Okay. Anybody else got any more questions? Yes, sir.
So I have a question about when the program going to start, like if you want to start.
Okay, well now the way we have it set up here, this is a while loop in LabVIEW. So what can stop it? There's two options. There's the overall stop button up here, which stops everything. Or if you go to the front panel, which is the other companion half of the two windows in LabVIEW, you can set up you can replace this with a control, and then there's your stop button in the front. So I can run that and then hit stop, and it would stop my program. Okay.
If you wanted to make it stop like from the website.
You just hit reset. That'll pretty much stop anything that's going on. It'll just reload the code. Or you can just hit the motor off button if you want to as well, if it gets running out of control. Which these robots are geared pretty low, so they don't run away too fast. So it should be okay. Alright, so the next thing I want to take note of is, let's go back to the source code. Sounds like we're in the matrix, it's okay. And see kind of what they did here. So actually the guys at SparkFun are actually pretty fun. If you look up at the comments here, it says this is beerware. So if you want to use it, please buy me or any other SparkFun employee a cold beverage next time you run into one of us at the local. So they actually sprinkle in some pretty nice, pretty funny comments as we go through here.
Surrogate recipient.
So
Ben is not, because he doesn't.
this is yes. So this is actually a really well documented code. So hopefully we can follow suit with some of our stuff in LabVIEW as well. But anyway, you don't need to know what some of this stuff is doing. They're basically creating a public class and then making new instances of it. But the thing that we're worried about is how to get the robot to actually move. So if we go under, see if I can find it right here. Let's look for left forward. FWD. Alright, so we've got a function called left forward. We'll get the first one going here. It's declared in this file. So this is the header file where it just defines the couple of functions that we're looking for. So most of y'all used the function called drive, correct? You just said drive, send it something. Okay, that's being declared here.
For the first one, but when they needed to make turns, you can't do that.
Yeah. So that's when you can define the left motor and right motor. So essentially, when you say RedBot motors space motors, you're making a new instance of this class. Again, you don't need to know some of the programming terms of this, but this is where these functions are. So let's take a look at the C++ file for the RedBot. This should get a little more interesting for us. And let's go and find, let's see, maybe back in the header file. I had this open on the other computer. Let's see. Da-ba-da. See if I can find a drive. So essentially what they've done, as soon as I find this here in a minute, is they have combined the left move and right move to get the drive speed. Okay, so let's see, where is this at? Yeah, so yeah, they're left forward and left reverse, right forward and right reverse. So they've made a couple different functions in order to make the drive function work. Okay, so let's see, I thought it was in here. Let me go to a different file. I've had a couple of these open today. Yeah, maybe it's the CPP. Okay, this should be it. Let's go up here and find what they're making. Again, this is the same kind of thing. So anyway, I'm not finding it right now. But anyway, if you search in some of the source files, which you're not going to do anyway, so I'm not going to waste any more time on it, you're going to find where they've defined the inputs and outputs for the digital drive. So on the actual RedBot itself, you plug in the motors to a certain pin. So they've translated that into the actual code. So if we look at the Arduino schematic, or I guess the pinout rather, out of Arduino, I'll just choose one of these. All these pictures are really good, so it doesn't matter which one you choose. So the ones we're looking at here, this is for an older version, but the pinouts are still exactly the same. So if we look at pins 5 and 6, those are our PWM pins. Okay, y'all went over PWM, right? A little bit, or you know what the concept is?
Not that much.
Okay, that's fine. So pulse width modulation sends something out, square wave. Okay. Note that pins 4, 2, 4, 7, 8, those have no tildes beside them. That means they're just straight up digital I/O pins. The ones that have the tilde are the PWM pins. Okay, those are what's going to be important to us. Okay, so let me go ahead and reveal the surprise. If we don't have a whole lot of time, I'll go ahead and Look up Lab 7. So basically I did the same thing earlier that I've saved, and I'm going to open that up. Alright, where did you go? Let's open up a project into here. There we go. Okay, well, it's for different versions, so we're just going to do it again. Alright, so let's go ahead and open up Lab 7 again. Alright, so if you read the documentation, you're going to find that the PWM pin they're using for the left motor is 5, and the 6 PWM they're using for 6. So remember I told you earlier that essentially this motor controller uses 3 pins, 2 for the left control, right control, left control 1, left control 2, right control 1, right control 2. They've already defined those pins. Okay, we actually saw that in the source code. So let's go and work on the left motor first. Let's just do one motor. Okay, so let's open up the main VI that we're looking for. Where did that go? Normally my resolution isn't this small, so I can see stuff. Oh, it pulls up nice over there. My screen's like this little over here, so bear with me for just a second. Alright, here we go. Alright, so let's go ahead and start afresh. So what's the first thing we're going to need? We're going to need our initialization. We're going to need our close. Let's make a quick while loop. Now we're going to have to initialize the pins, okay? So let's go ahead and initialize all 3 digital pins. So 2 of them are just straight up digital I/O pins, 1 of them is a special PWM pin. And it turns out that there's actually a special initialization just for a PWM pin called PWM Config port, or config pin, okay? So let's go ahead and configure. And if you actually look inside the VI, in case you're not familiar, if you double click on one of the little boxes, that's what's called a sub VI, you can expand and keep going deeper into the tree, if you will. Okay? So essentially 3, 5, and 6 is what the PWM pins we're looking for, which makes sense because we have pins 3, 5, and 6 over here. Okay, so they've just copied this verbatim. So in our case, I think pin 5 was the left, we'll see here in a moment. So I'm going to go ahead and close that out and create a constant over here for the PWM pin. Just create a constant, pin 5. Okay. Again, you got to tie in the Arduino source, I think it's called. Yeah. And you can have your error in as well if you want to. That's fine. We got 2 more digital pins we have to set up for the pin modes, just like you would in Arduino. So let's make 2 of those. Tie that into the source as well. And let's go ahead and create a constant for this one and a constant for this one. Alright, I need to go back to the header file here to see what that was. So the path for this, since we're going to go through, it's going to be in the program or the recording as well. It's going to see program files. This will be on the computers in the lab. Under National Instruments, be under LabVIEW. In your case, 2015. Mine's 2014. VI lib. It'll be under LabVIEW for interface for Arduino. There's the firmware. There's the base. So I wanted to go through showing you where that was. Okay, that's where the base file is. So let's go ahead and go back here. Look at the very top of the header file. So left control for us is pin 2. Left control 2 is pin 4. So 2 and 4 are the ones we're looking for. So let's go ahead and initialize pin 2 and pin 4. Now should those be inputs or outputs for driving a motor? Okay. So let's create a constant as a output. Move that over here slightly. I'll go ahead and copy that, save some time. Okay, so now we declared Pin 2 and 4 is an output, and also declared PWM pin 5 as a PWM pin we're concerned of. Okay, so let's go ahead and run these into here. Okay, so again, let's just make the wheel spin one direction and spin the other direction. Let's do that. So we'll put another flat sequence in here. That was the example that I had spooled up if it wasn't for a different version of LabVIEW. So that's fine. Does anybody have a newer version than 2015 downloaded to their personal computer? Okay, so you'll run into this problem too. You'll have to do what's called file save for previous version if you want to transfer something to one of the lab computers. So that's going to be 2015. So LabVIEW is forward compatible. It should be backwards compatible, but not forwards compatible. So it's kind of stinks in that manner. But
You don't really have to do that if you use the live computer, right?
I'm sorry.
You don't really have to worry about that unless we use a live
Exactly. Yeah, if you're going to use your now, if you have your personal one, you're going to have to download the LabVIEW for Arduino interface, and I can show you that offline how to do that. Is anybody else going to use their personal computer for this? Okay, I'll show you both offline later. Okay. All right. So let's go ahead and focus on this. So let's say left motor forward, and we'll do left motor reverse. All right. So let's go ahead and tie in some digital I/O pins. So let's do a digital write down here. 2 of those because we got to write pin 2 and pin 4. So we're going to run this into here, this one into here. Also the error outs will follow as well. You usually don't have to do this, but it's pretty good practice in LabVIEW to keep the errors flowing. If anybody's OCD like me, you'll spend hours trying to get the line perfectly straight. So you have no idea how much of this is killing me inside right now. So it's okay. But I'm going to endure it for you, okay? Yeah, but it doesn't clean up the way I want it to. It's too bad. I've tried for years, but it just doesn't do it. I've even complained to NI about it, but they don't listen to me. All right, so in this case, just like we've talked about in class before with Dr. Conrad, let's just choose one of these as enable, the other one disable. This should be one direction. We'll figure out if it's forward or reverse. I can't remember on top of my head now which one it is. Let's go ahead and, or excuse me, the pin has to be the same. This would be pin 2 and pin 4. Sorry, the next option is the actual value of the pin. So that's the value. So create a constant. Let's keep that at 0, and we'll change the bottom one to 1. If it turns out to be the wrong one, we can just change it around pretty easily. All right, we also want to put a delay in here, again, under timing, wait milliseconds. Let's just wait for half a second this time, just to speed things up. Same thing on the other side. I'll go ahead and copy this so far. So again, same thing over here, except we're just going to change the, hope it wasn't TI 89. 85, okay, we're good then. All right. Oh wow, we're really good. The old ones are built like tanks, the newer ones not so much. All right. Yeah, I had a TI 86 for most of my undergrad days. All right, so again, this is either going to be opposite or exactly correct. So I'm not a very lucky person, so it's probably going to be completely opposite. But it's okay. All right, so let's go ahead and make a PWM write. So, okay, we're going to go here. We're going to choose what pin we want the PWM to go on, so we're going to create a constant. In this case, we're working with pin 5. We're just doing the left motor. Okay, this will have to be repeated, of course, for the right motor. So let's go ahead and tie in this to the PWM and this to the air out. Okay. All right, so in this case, the duty cycle is just going to determine the speed. Again, this 0 and this 1 determines the direction, just like you went over in class. So 0, 1 is either going to be forward or reverse, and then 1, 0 is either going to be forward or reverse. We're going to figure that out in a minute. So what was the maximum number you could set for your speed? Do you remember? Same thing here, okay? So we can create a constant. I'm not going to go quite that fast. I'm going to do about 100. Okay. Same thing over here. Just copy all that over here. So hopefully at this point you become very appreciative of the class structure and all the stuff they did in Arduino to simplify stuff down. Okay, so if anything, you'll get an appreciation for that. All right, so last thing we're going to try to do, let's go ahead and take one of these resources out. Mainly because you can't tie the outs together, it's going to give you an error. Just having one of those pass through is fine. Okay.
By the way, you're not going to drive them off the table.
Huh? I've got the motors off, so until I get over here, okay, that's fine. All right. So let's go ahead and take one of the error outs and bring it into here, and let's just create a control for the function here, or for the while loop. All right. So any questions so far on what we've done? Everybody good?
So you only need one output for the close.
Yeah. Yeah. So I'm sorry.
Let's see if it's accurate.
Yeah. So basically, what these do is you have to tell it what Arduino board you're working with. That kind of just filtrates through, and at the very end, you can just close it. So essentially, what I could have done is just had one of these from here, pull into here, and then this one could go up here, this one could go up here as well. And we'll do that in a minute. We'll create a sub VI. I want to go through that as well for in a few minutes I've got left. All right. So let's go ahead and run this code. So I'll leave the stop button up top here. Go ahead and run it.
You're going to
Turn the motors on. Go ahead and reset the board. Make sure everything's on. I got to plug the battery in, because that's how it gets power to the motors. And the reset. Alright, so let me turn on the start cam here. Zoom out. Oh, there's that error I was talking about. So I didn't plug it in quite fast enough. So you might get an error similar to that one, okay? Just say stop. We'll go ahead and rerun this. Hit reset. It should go forward and backwards. Oh, hit the wrong button, sorry. So let me reset before I start it. Alright, so the board has to be sort of ready whenever you start it. Come on. Alright. There we go. So now I can reset and then hit play. Okay. Alright. Another thing you can do as LabVIEW as well is do what's called probes. This is how you do some debugging. So I can sit right here and see what the actual value of this stuff is, if it's executed or not. I also can see if a certain part is executed, so I can hit the high execution mode and I can reset the board, turn the motor on. Alright, so in this case we got that error I was talking about. I intentionally did that so we could see the error. So you actually can go in here and look at the error. It'll come back. So it's error 5003. You have to look that up online. Okay, so I wish that LabVIEW had a little bit better help option for that. So let me go ahead and run these into here, just so I can have a complete video for everyone. So I could just have easily run, somebody had a question about this, I could run all of this just from this top one here, and then fed each one of these into just the very top one. Okay, it's the same exact thing. Okay, I could have deleted this one, and that one. Okay, you could just run everything from just one.
Can we save this block here? Open Arduino Schematic one direction.
Oh yeah. I mean, the fact that I did constants on these are just to demonstrate the base functionality. But you can change those two controls and mess around with them. Have that dependent on something else. I mean, you can do just like you would do in regular C.
It would just look like a block and call it later.
Yeah. So if you want, for instance, let's just do that for once. So let's change this to a control for the duty cycle. So I can change to a control. I can view that as an icon. That'll show up on the front panel as a value that I can just write to. So I can say 100. If I want to, it should be 100.
What if I want to call it another VI?
We can talk about that when we get a little more into it. Let's get the motor going the right direction first, okay? All right, so any other questions so far? Everybody okay? All right.
So exactly what's happening is it's saying it's writing pin 2 low, pin 4 high, and 5 controlling 5's
5 is the PWM pin. So left motor has a PWM pin and right motor has a PWM pin. So the first two digitals control the direction. So this 0 and this 1 determine if it's going forward or reverse. And then the very last PWM determines the speed. So speed doesn't have anything to do with direction. So 0 to 255 is just how fast you're going in that direction. Well, no, it actually is already plugged in. So that's what we looked at the source code for, to see what they define that as from SparkFun. Okay. Normally, if you was on a different board, you would plug those two pins into the PWM pin of the other board. Make sense?
Yeah.
All right, cool. Any other questions? All right, cool.
So the question is for pin 2 and pin 4, it's not necessarily a 0 is forward and the 1 is reverse. For one of those pins, you actually have to set it as 0 of one and 1 of the other. What happens if you set it both at 1?
Blows up? No. I have to go back and look and see what that particular motor controller does. I'm just going by their code. So I got this done about 10 minutes ago. So just exit that out of the video. All right. So let me go ahead and reset this here and put the motors to run. All right, sweet. All right, so far so good. All right, so if I want to get the right motors going, again, it's the exact same functionality, okay? And again, I'm going to have these VIs available for everyone online. So let's go ahead. We're not going to do the right motor. What we're going to do is encapsulate all of what we did into a sub-VI. So to clean up your code quite a bit, just like you've done before with functions. So a lot of people I saw, grading some last reports. So if you suck for the obstacle course, y'all have 3 main functions: line follow, ramp, and then maze, correct? So that cleans up your code very nicely. So just like that in C, we can do the same thing in LabVIEW. So what we can do is we can select, I'm going to trade this back out. Let me disable view in the label to clean this up a little bit. So what we can do is encapsulate all of this information here. Let me actually get rid of these error outs here. We can combine the errors here in a minute. Alright, so I can encapsulate all of this. So essentially I would have one input for the Arduino source and one input for the motor speed, and have one output as the Arduino source on the output. Okay, so I can go ahead and highlight everything here. I can say edit, create sub-VI. Okay, it'll encapsulate all that inside of a block. So now you know that basically all of these here are basically just sub-VIs that somebody else has made. Think about that as functions other people have made. It's the exact same thing. So this is not required, but I'll have it for video purposes here. You can edit the icon to make it be a little bit more reasonable. I can go into here and clear this right here out and make it say something cool like left motor, if you will. So let's change that to black. Change it to a box. And I can fill this into here. And let's just make some text called left motor forward WD. Let's make that black as well. I can say OK. Now what will happen, it changes up here and also changes inside of your code. Okay, so that way it you can kind of give it yourself a little quick snippet of what's supposed to be inside. You can double click on it at any time, and exactly what we had before is inside that sub-VI now. It's the same thing as functions. Okay, let's. Yeah, once you start compartmentalizing stuff up, it's fine. But the only bad thing about that is it's hard to debug. So you want to get most of the bugs out of something before you encapsulate into a sub-VI. You want to make sure that works very well. Yes.
So the purpose of the sub-VI is to make the code.
Yeah, to clean up your code quite a bit, because this is, of course, a pretty easy example. But as you move forward and stuff with the Danny, you're going to need to encapsulate more and more information. Okay.
So can you undo that and go back to the list once you make the sub-VI?
Oh, you can just do Control-Z and get back if you want to.
Well, like if you have it.
Oh yeah, so what if I wanted to go back, for instance, I could double click inside of here. I could go back to the original code, just select this stuff here, Control-C that, delete the sub VI. It is a little harder going back. Okay, I wish they had a revert function. That'd be actually a pretty cool feature to have. All right, so let's keep moving forward here. So it's going to ask you to save this particular sub VI as something. So I can save this as left motor forward. And of course, that's going to be in the same directory as your project. Okay. And the reason why we want to do a project is so we can see in our project tree what was underneath of it. So there's left motor forward. Okay. All right. So let's go ahead and make one more sub VI over here. So we're going to encapsulate all of this information here. In this case, let's just have a constant over here. Move this 5 back over to here. And then we should have, let's get rid of this error out here. I just want to have one input and one output. So let's go ahead and encapsulate this again. Edit, create sub VI. And in this case, we can just make it say right motor. So let's go ahead and go to layers, kill this guy, make an outline. Let's make this one green, just be something different. And we can say left motor reverse. Okay. And that kind of tells us something's going to be inside. I can say that as left motor reverse. Okay. Alright, so now there's our base. Okay, so I made a mistake, and here's what the final version should look like for your VI. Thanks. Basic, moving the motor, okay, left or right. So essentially you'd have to have a right motor forward and right motor reverse. Then you actually could encapsulate both of that to just have a drive function. That makes sense. You could just encapsulate both of those to have a drive function. And if you want to go look at their example, again, if you go to the source code and look at their particular programs, we actually can see how they define some of this stuff. So they have left and right motor encapsulated inside of here. Where did this go? I want to be able to show you that. It's not critical, but still something worth to look at. Let's go to, yeah, RedBot motors. Here it is. Okay. So remember, you make that RedBot motor space motors. That's essentially what you do in LabVIEW or in Arduino. So here's where they've defined all of these functionalities. So if you look at here, just for your future reference, so red motors, the double colon means that's part of that same class, and this is an instance of that class of stop. So stop is just left stop and right stop. So it's two sub-functions. So if we kind of go to the drive function, the drive function is only a left forward and right forward encapsulated together, else a left reverse, right reverse. Okay, so that's based on the speed. So basically that's exactly what we just got through mimicking to move it forward. Okay, so any questions so far? We're just about done. Okay. Alright, so essentially what I'd like for everybody to do to kind of get your feet wet in LabVIEW in preparation for the Danny robot once we get it fixed is we're going to redo the square again, except we're going to be using the LabVIEW functionality. Okay, so that should be able to get your feet wet in LabVIEW and making some sub VIs. I'll go ahead and post that as soon as I get back to the lab before you get out of class. Okay, that makes sense? Yes. No, it's just going to be drive forward for a certain amount of time. So essentially you would have a same flat sequence. You would just change your delays for your forward. And of course, a 90-degree turn would be what you would just change the ones and zeros to make it turn one motor on, one motor to the reverse direction. That should be challenging enough to kind of get that going for a little bit in LabVIEW. Okay. Does that make sense to everybody? So I think that was what, lab 4 or 3 when we did the square. I think it was 4. So basically it's lab 4 except with using LabVIEW versus Arduino. Okay. I'm sorry. Yeah, yes, the same requirement. So 3 times around the square. Okay. I mean, if you want to get really into it and see what pin the motor encoders are and read those in the LabVIEW too, you can go at it. But The minimal requirements would be just go around the square 3 times. Okay. So that's sort of we were supposed to do the same thing with the Danny robot, but the coding would have been very similar to this. Okay. Also, this is what the VI package manager should look like whenever it comes up. Thank you.